Welcome back to the morning show, 726 here. Time for part two of our Chemist Corner segment. Jesse Miller, teaching lab specialist and REACT program director at the U of I, rejoins us. Now, we talked about chili eating. Maybe those folks had something afterwards, but this is a different type of gas.
Well,
gases matter.
Well, you know, all gases are gases. It just depends on what it's made of. And some gases are heavy and some gases are light. And that's one of the things I was going to talk about. You know, one of the things about, like, when you smell something, volatile compound, some things you'll be able to smell it much faster. Like if somebody wears some heavy perfume and they're walking across the room over there, and you might, maybe in 30 seconds to a minute, you'll be able to smell it.
Sure.
But other perfumes you can't. Now, that has to do with how heavy the molecule is and how fast it goes. Okay. Now, we're going to start this off because it's going to take a minute for it to see. Now, this is some smelly stuff, so I apologize.
What is that?
This is ammonia.
Oh, okay. I think everyone knows what ammonia smells like.
And it's concentrated ammonia, so it's really smelly. And this is hydrochloric acid. Okay. And it's very concentrated too, so try not to breathe that. And what I'm going to do here is try to... You're
the one that's in the middle of all this.
Yeah, I know. I'm going to try to get these go in at the same time, so we're not cheating. Okay.
Well, we're genetically disposed to do that.
That's what I hear. Okay. So we'll get this in here. We got the ammonia on one side and the hydrochloric acid on the other side. We'll cork this off here. Okay, now, what we're going to see here, because hydrochloric acid and ammonia will form ammonia chloride, and somewhere, yeah, I know, it's pretty smelly, somewhere in here we're going to see a ring form, and it's pretty spectacular, and where that ring's going to form has to do with how fast it travels. Okay. Now, I said it has to do with weight. Turns out, and I get this, it's inversely proportional to the square of the ratio of the masses. So
what was that?
Yeah, inversely proportional to the square of the ratio of the masses. So ammonia has a molecular mass of about 18, and hydrochloric acid has a mass of about 36. Okay, so if you take the square root, that's 6, and that's about 4. So the ratio of that's, well, this over this is 2/3. Sure. So the ammonia, or the hydrochloric acid, will travel about 2/3 as fast as the ammonia. So the ammonia, when this ring forms, well, it should form a little bit to the left, or my left, your right, the video viewing audience is right, of center. And it takes a little bit because, you know, we're talking about Brownian motion and natural convection, but still there's a finite amount of speed, and it's a very complicated formula to figure out exactly how fast, because it has to do with diffusion constants and all that stuff. Got it. And if we're starting to see,
I can see a little.
There, you can see this ring
the
ring.
I don't know if our cameras can pick that up, but it's right here, Don, if you want to get up where my finger is. Yeah, we can see it.
Yeah, it's starting to form there, and you can see it's just to the right of center for the camera's view, our left. And because the ammonia, a little more. That's right. The ammonia travels faster than the hydrochloric acid, because it's heavier.
Interesting.
So, yeah, so depending upon what you've eaten, so to speak.
Depending on how fast it travels.
That's right. From the living room to the bathroom. All
right. Very good. Very cool, Jesse. Well, thanks for coming in. We appreciate your time, as always. Yeah, it's a little pungent in here, but that's all right. All right, if you want to see a replay of the segment, just go to our website, IllinoisHomepage.net. Look on the morning show. Look under Chemist's Corner. We'll be right back with your headlines and weather.